Welcome pre-cal students to the homework help video, page 225. Let's go ahead and get started with these 13 problems, okay? Let's take a look at number 39. We're going to find the limit of this expression here as x approaches 5. Now, if you put 5 in for x, you will get 0 over 0, okay? So, that's not going to work. Substitution is not going to work. So let's try to simplify this expression. X minus 5 over. Now, like I told you guys the first week of class, I'm not going to reteach factoring. Factoring is something you must know, and you must be able to do it at all times in pre-calculus, okay? So I have a square. This is a perfect square. Perfect square. The first term is positive, second term is negative. So the factorization would be square root of x squared is x. Square root of 25 is 5. Make one positive, make one negative, okay? So I left the numerator alone. I factored the denominator. This would cancel with this. So you're left with 1 over x plus 5. So instead of using this expression here, I'm now going to use this expression here. So we're going to find the limit of this expression as x approaches 5. So where the x is right here, I will substitute 5. So 1 over 5 plus 5 is 1/10. So the limit of this expression here as x is approaching 5 is 1/10. Let's take a look at number 40. The exact same thing. If you put 2 in for x, you will get a 0 up top and you get a 0 in the bottom. So that's not going to help, okay? So next we need to try to simplify this expression. Let's see what we have. I'm going to leave the numerator 2 minus x, okay? And the denominator, once again we have a perfect square. Perfect square, first term is positive, second term is negative. So the factorization would be square root of x squared is x. Square root of 4 is 2. Make one positive, make one negative. Now students, look, we almost have it. I don't have x minus 2, I have 2 minus x. So what can I do to change this? Well, I'll tell you what you can do. You can factor out a negative 1. Now watch this carefully. You can pull out a negative 1. And when you do, that makes it a negative 2 and a positive x. Now watch how I can prove that to you. Mr. Earhart, you can't just stick a negative 1 on the outside. Yes, I can. If, when I multiply this negative 1 back through, I get what I started with, and I do. Negative times a negative is positive. Negative times a positive is negative. So I factor out a negative 1 up top, and that leaves me with negative 2 plus x, which is the same thing as x minus 2. There we go. So this cancels with this, and I'm left with negative 1 over x plus 2. So I'm going to use this function in place of this function up here. Alright, so here we go. The limit of this function here as x approaches 2. So where the x is, I'm going to put a 2. So negative 1 over 2 plus 2. That's negative 1 over 4, or negative 1/4. So the limit of this expression here as x is approaching 2 is negative 1/4. Alright, let's move on to number 41. Same thing again. If you put a negative 3 in up here or down here, you'll get 0 over 0. Okay, so I'm going to factor the top and factor the bottom. Here we go. The top, if I factor it, is going to be what two numbers multiply together give me a negative 6, but when add together give me a positive 1. Well, the answer is positive 3 and negative 2. Now for the denominator, once again I have perfect square. Perfect square, first term is positive, second term is negative. Okay, so the factorization of that would be the square root of x squared is x. The square root of 9 is 3. Make one positive, make one negative. So this would cancel with this. And now I'm going to replace this expression here with this expression here. So now I'm going to find the limit of this this expression here as x is approaching negative 3. So where this x is, I will put a negative 3. Where this x is, I'll put a negative 3. And I end up with negative 5 over negative 9. That's incorrect. Negative 5 over negative 6. Negative over a negative is a positive. So my answer would be positive 5/6. So the limit of this expression here as x approaches negative 3 is 5/6. Alright, moving on to 42. Okay, if I put a 4 in, I would get 16. Negative 4, I'd get a 0 here. 16, yep, I get a 0 here. So I can't use direct substitution or analytically. I can't solve it analytically unless I first simplify this fraction, okay? Now notice I always try, students, to substitute this number in first if I can, okay? But it didn't work. So what two numbers when multiplied together give you 4? When add together give you negative 5. I'm thinking of a negative 4 and a negative 1. If you multiply them, you get 4. If you combine them, you get negative 5. Now for the denominator, what two numbers when multiplied together give you negative 8? When add together give you a negative 2. Well, that's going to be a negative 4 and a positive 2. If you multiply them, you get negative 8. If you combine them, you get negative 2. So these cancel. So now we're trying to find the limit as x approaches 4 of x minus 1 over x plus 2. Alright? So everywhere there's an x, I'm going to substitute 4. So I would then have 4 minus 1 for the numerator and 4 plus 2 for the denominator, which would give me 3/6, which would give me 1/2. So the limit of this expression here as x is approaching 4 is 1/2. Okay, moving on to number 43. Now here's where we get to the conjugate, okay, or the rationalizing the numerator. If you were to put a 0 in for x, you would get 0 over 0. So that's not going to help us. So next we're going to try to simplify what we have here. Well, I'm going to multiply this entire fraction here by the conjugate of my numerator. Now the conjugate of my numerator would be, we leave the first term alone, and we change the sign of the second term. So this negative sign becomes a positive. Now whatever you put here, you're going to put down here in the denominator, okay? And here we go. Remember, whenever you're multiplying two conjugates together, you just take the first term times the first term and the second term times the second term. It's a shortcut. The square root of x plus 5 times the square root of x plus 5 is x plus 5. The square root of 5 times the square root of 5, negative times a positive, would be negative 5. Alright? Now I'm going to take x times this whole group right here, and I'm going to leave it like that. I'm going to put x and then parentheses x plus 5 plus square root of 5. Alright? Now for my numerator up here, x plus 5 minus 5 is obviously just going to be x. Okay? Because your positive 5 and your negative 5 would cancel. Next, your x's right here cancel. So you end up with 1 over the square root of x plus 5 plus square root of 5. So I'm going to use this expression in place of this expression right here. So I'm going to find the limit of this expression as x is approaching 0. So here we go. 1 over, put a 0 in for x right here. 0 plus 5 is square root of 5, so I really have square root of 5 plus square root of 5, that's 2 square root of 5. Now that would be your answer normally, okay? But remember, in the higher level math, we never want any answer to have a square root in the denominator, so I'm going to rationalize the denominator by multiplying the top and the bottom by the square root of 5, okay? When I do that, I get 1 times square root of 5 is square root of 5. 2 square root of 5 times 1 square root of 5 would be, well, there's a 1 right here. 2 times 1 is 2. Square root of 5 times square root of 5 is square root of 25. Of course, the square root of 25 is just 5. So we have 2 times 5, which is 10. So the limit of this expression here as x is approaching 0 is square root of 5 over 10. Alright, square root of 5 over 10. Alright, moving on to number 44, same thing. We're going to rationalize the numerator. Alright, we're going to rationalize the numerator. And here we go. I'm going to multiply the top and the bottom by the conjugate of the numerator. So square root of 2 plus x plus square root of 2. Alright. And we'll multiply the top and the bottom by this. Well, whenever you're multiplying two conjugates together, you multiply the first term times the first term, second term by the second term. So square root of 2 plus x times square root of 2 plus x is simply 2 plus x. Negative times a positive is negative. Square root of 2 times square root of 2 is 2. Alright. Now your denominator would be x parentheses square root of 2 plus x plus square root of 2. Alright. Now in your numerator here, your positive 2 and your negative 2 would cancel, leaving you with just x. And then notice your x's cancel. So you're left with 1 over square root of 2 plus x plus square root of 2. Alright, so this has replaced this up here. Alright, so I'm going to find the limit of this expression here as x is approaching 0. Alright, so looks pretty much like a carbon copy of the last problem that we did. Here's the x. I'm going to put a 0 right here for x. 2 plus 0 is 2. So I have square root of 2 plus square root of 2. So I end up getting 1 over 2 square root of 2. Now, that would normally be a great answer, but we don't want our final answer to have a square root in the denominator. So we're going to rationalize the denominator by multiplying the top and the bottom by the square root of 2. Alright? 1 times square root of 2 is square root of 2. There's a 1 right here, even though you can't see it. 2 square root of 2 times 1 square root of 2. Well, 2 times 1 is 2. Square root of 2 times square root of 2 is square root of 4. Of course, the square root of 4 is just really 2. So we have 2 times 2, which is 4. Please do not try to reduce an inside number with an outside number. That is incorrect. You can't do that. Same with the last problem. Don't try to reduce an inside number, a number that's inside the radical, with a number that's outside, okay? So the answer to number 44 would be square root of 2 over 4. Moving on to number 45. Well, once again, same thing. If we put a 4 in, we're going to get 0 over 0, so that's not going to work. So we're going to rationalize the numerator. So we have x. It would be x plus 5 plus 3. This is the conjugate of this right here. Alright, so this is what we're going to use. So we'll multiply the top times the top and the bottom times the bottom. Now, remember, whenever you're multiplying conjugates together, you multiply the first term times the first term, last term times the last term. So square root of x plus 5 times square root of x plus 5 would simply be x plus 5. Alright? And negative 3 times positive 3 would be negative 9. All over. Now let's be really, really careful here, okay? We're going to take x minus 4 times this whole expression right here. Now sometimes students, you can kind of look at it and think, I mean, yes, if you're taking a 2-termer, 1, 2 times a 2-termer, you take x times this, and then x times 3, then you take 4 times this, and then 4 times 3. That's true. That's what you should do. But sometimes you can look ahead and use common sense. Look back at your numerator. Before you multiply denominator times denominator, what what's x plus 5 minus 9? If you were to take positive 5 minus 9, that gives you x minus 4. Well, notice x minus 4 matches this. So instead of multiplying all of this through, I'm just going to put x minus 4 times the square root of x plus 5 plus 3. There we go. And now these x minus 4 would cancel out, and you're left with 1 over the square root of x plus 5 plus 3. Alright? And so now this function here is going to replace this function right here with this expression. So the limit of this expression as x is approaching 4. So where the x is right here, I'm going to put a 4. We can do a lot of this in our head, guys. 4 plus 5 is 9. So we have the square root of 9. Okay? 4 plus 5 is 9. The square root of 9 is 3. And 3 plus 3 is 6. So I end up with 1/6 with my answer. And that would be the limit. The answer is number 45. Alright, number 46. Well, same thing again, students, so we're going to keep doing this, okay? The conjugate for the top would be the square root of x plus 1 plus 2. That would be the conjugate of the top right there. So we're going to multiply the top and the bottom of the fraction by the conjugate. So there we go. Well, we're multiplying two conjugates up top. So first term times first term would be x plus 1. And negative 2 times positive 2 would be negative 4. Alright? So your entire numerator becomes what? 1 minus 4 is negative 3. So your entire numerator becomes x minus 3. Now look at your denominator. You're taking x minus 3 times this entire expression here. So we really have x minus 3 times the square root of x plus 1 plus 2. Okay? These will cancel right here, leaving you with 1 over the square root of x plus 1 plus 2. So we're going to find the limit as x approaches 3. So where the x is right here, I'm going to put a 3. 3 plus 1 is 4. So I really have the square root of 4. And the square root of 4 is 2. So 2 plus 2 is 4. So the limit of this entire expression here as x approaches 3 is 1/4. Okay? 1/4. Now moving on to number 47. Now, if you put a 0 in, you can see right away it's going to fail because we're going to have a 0 here plus we'll have a 0 up top too. We'll have 0 over 0. So we're going to have to simplify this expression right here. Alright? Now here's how I recommend that we do this. You first have 1 over 3 plus x minus 1/3. All of that is over x. Now, I would like to suggest that we combine these two fractions. Now, in order to do that, we must have a common denominator. So I have a 3 plus x here as a 2-termer and a 1-termer here. The common denominator for those two fractions would be 3 plus x, then a minus sign, and then 3 plus x. That would be all over, of course, this right here, which is still x. Now, let's see what happens here. What do I have extra here that I don't have here? Well, this 3 right here. So you must also multiply the top by 3. And you bring over your 1. So you really have 1 times 3, which of course is just 3. Let's look at it like this. Are you ready? What do I have extra here that I don't have here? 3. So multiply that by the top. 1 times 3 is 3. Now, what do you have extra here that you don't have here? 3 plus x. So we're going to take 1 times 3 plus x, which will give us 3 plus x. Now, next, I'm going to put these two fractions together. Be careful. This negative sign goes to this whole term. So it's going to be 3 minus 3 minus x all over 3 plus x. Let's go over that again, okay? Look, I have 3 minus 3 plus x. 3 minus this whole expression. So it's here divided by x. So let's write that out, okay? This top fraction here divided by what? X over 1, which of course would be the same thing as multiplying 1 over x. You flip the fraction. Now look at this. 3 minus 3 minus x. Well, 3 minus 3 cancels. We're left with negative x. Well, this x here will cancel with this x here. There's a negative sign here, leaving you with a negative 1. So negative 1 times 1 is negative 1. And 3 plus x times 1 is going to be 3 parentheses 3 plus x. So this entire expression here takes the place of this expression here. So I'm going to find the limit as x approaches 0 of this expression here. Alright, so we can do this in our head. Put a 0 right here for x. 3 plus 0 is 3. 3 times 3 is 9. So you have negative 1 over 9, which is a negative 1/9, okay? Let me check the answers real quick, and yes, that is correct. Alright, moving on to 48. Well, students, we have the exact same problem almost again. So here we go. I have 1 over x plus 4 minus 1/4 all over x. Well, let's get a common denominator for these two fractions. My common denominator would be 4 parentheses x plus 4. Then bring your minus sign over. And then once again, 4 parentheses x plus 4. Alright, what do I have extra here that I don't have here? A 4. Multiply that times the top and you'll get a 4 right here. What do I have extra here that I don't have here? X plus 4 times 1 would simply be x plus 4. And all of this is over x. Okay, now let's combine these two fractions. We have 4 minus this whole expression. So it would be 4 minus x minus 4 all over the common denominator, which is 4x plus 4. Okay, now that's divided by x, or that's all over x. So it's divided by x. But of course, if it's divided by x, we could really say it's times 1 over x. Now negative 4 is going to cancel out, leaving you with a negative x. So your x cancels with this x, leaving you with a negative 1 right here. So negative 1 times 1 is negative 1. 4 times x plus 4 is going to be 4x plus 4. Okay, now let's go ahead and find the limit. What we have now is this expression here replaces this expression here. So instead of finding the limit of this expression, we're going to find the limit of this expression here as x approaches 0. So where the x is, I'm going to put a 0. 0 plus 4 is 4. 4 times 4 is 16. So I have negative 1 over 16, or in other words, negative 1/16 for number 48. Alright, let's continue on. Now the next ones here are going to be a little interesting. Let's see what happens, okay? I'm going to put delta x as delta x approaches 0. So everywhere there's a delta x, I'm going to put a 0. So you put a 0 here. A 0 here. If you simplify, trust me, excuse me for yawning, you'll get 0 over 0. Okay? So we're going to have to simplify this expression up here. Now, the first thing I think to do is if I take this 2 and multiply it through, I will get 2x plus 2 delta x minus 2x all over delta x. See how I did that? Now why would I do that? Because I can see now my 2x will cancel with my negative 2x. And I'm left with 2 delta x over delta x. Now, these would also cancel, leaving you with 2 over 1, or just 2. So I'm trying to find the limit as delta x approaches 0. I'm trying to find the limit of 2. Well, we haven't learned this yet, but I knew we'd stumble across it sooner or later. Anytime you're taking the limit of a number, I don't care what x or delta x is approaching, the answer is always just this number here. So we're taking the limit of 2 as delta x is approaching 0. Because we have a whole number here, the answer is just 2. So the limit of this entire expression here is this. If you were to put 0 in for delta x, we know for sure we'd have a 0 in the denominator. So that's enough to tell me right there I'm going to have to do something else. Now, Mr. Earhart, you taught us to simplify, to factor, to reduce, to rationalize the numerator. What are we doing now? Well, what we're doing, students, is we're trying to take this expression and simplify it. And we've done that many ways. We have factored, we have rationalized, but now none of that's going to work. So we're going to try to spread this out and see if something will cancel, okay? So x plus delta x squared means write the parentheses twice. So x plus delta x times x plus delta x minus x squared all over delta x. Now, up here in the top, take my x and multiply it through, then take your delta x and multiply it through. If you do that correctly, you will get this. You will get x squared plus delta x quantity squared. And then here we would have, let's see, 2x. This is correct, students. I want to break it down and show it to you a little easier, okay? So I'm just going to do it like this. I think I'm trying to go a little too fast here. Okay, x times x is x squared. X times delta x would not be delta x squared. That's not what you put. It's x times delta x, so it's x and then delta x. Alright, and then now we take delta x and multiply it through. Delta x times x would be x delta x, and then delta x times delta x would be delta x quantity squared. Now here we have x delta x delta x, so x plus x would be 2x delta x plus delta x squared. Alright, so I've taken this whole expression here, multiplied it out and got this right here, and simplified it down to this, okay? So if I did all that, now watch, that means I still have, students, a negative x squared to bring down and put right here. Alright, and it's going to be all over what? Delta x. And this should actually have a parentheses around it. There we go. Now, this is really, you might have to back this up and watch it a couple times to get this, okay? And if that's the case, I apologize. But, I want to make sure you guys get this, okay? Now, notice you have a positive x squared and a negative x squared. They're going to cancel out, okay? Now, you can cross off your delta x here, your delta x here, and your delta x here, alright? That leaves you with 2x plus delta x all over 1, or just 2x plus delta x. Now, what are we putting in for delta x? 0. So where delta x is right here, we're going to put 0. So we have 2x plus 0, which is 2x. So the derivative, the limit of this expression here as delta x approaches 0 is simply 2x plus 0, 2x. So your answer was not an actual number. It was actually an algebra expression, okay? Alright, one more and we will be finished. Here we go. Number 51. Alright, now, it looks like a lot more work than it actually is, okay? First of all, let's take this expression here, let's simplify it, okay? So I have x plus delta x squared, which means x plus delta x times x plus delta x. So take your x here and multiply it through. X times x is x squared. X times delta x is x delta x. Now we have delta x, we're going to multiply that through, okay? Delta x times x would be x delta x, and then delta x times delta x would be delta x quantity squared. So this whole expression right here is this, which is this right here, alright? So with that in mind, let's erase this, and let's pull this up here. expression here is this. Now I have negative 2, and I'm going to multiply that through, so negative 2 times x is negative 2x, and negative 2 times delta x is negative 2 delta x. Then I have a positive 1. Then I have a negative being multiplied through. That gives me a negative x squared. Negative times a negative, positive 2x. Negative times a positive is negative 1. Now let's combine like terms. For example, I have a positive x squared and a negative x squared, so they cancel out. I have a positive 1 right here and a negative 1. They're going to cancel out. I have a negative 2x right here and a positive 2x. They're going to cancel out. Now what else do I have? Let's see. I have x delta x, we'll add those together. We'll get 2x delta x, because x plus x is 2x. Then I have negative 2 delta x, and then delta x quantity squared all over delta x. So delta x would cancel with this, and with one of these, so we're left with 2x minus 2 plus delta x all over 1, which of course we don't need. Now, I've taken this entire original expression right here and simplified it all the way down to this right here. So now I'm going to take the limit of this expression as delta x is approaching 0. So everywhere there's a delta x, I'm going to put 0, which would be right here. So I really have 2x minus 2 plus 0, which would be 2x minus 2. Now let me check my answer real quick here, and that is correct. So the derivative of this entire expression as delta x is approaching 0 is not an actual number, it's an algebraic expression, and the answer is 2x minus 2. Okay, I really hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.